right, so let's begin this example at the end of the last example. All right, and the last example we were running the split race, and we found that you know you were at minus 20, right? You were at x equals minus 30 feet, and the leader was at x equals minus 20 feet from the finish line. Now what we want to do is we want to say, okay, well, if it's going to take you 2 seconds to reach the point where the leader is, how fast are you running, first? And 2, where is the leader after those 2 seconds, if the leader is moving at 4 meters per second? I mean, we talked about Zeno's paradoxes and stuff like that. This is sort of what would go into a mathematical analysis of that if you really wanted to do a mathematical analysis of that. So, right, this is minus 30 feet. This is minus 20 feet. And it takes you 2 seconds to get here. So our first question then is, how fast are you running personally, right? Let's see how we can do that. Let's see, we might want to start with the velocity, the average velocity, which is delta x over delta t, we just said in the lecture part. And that is your final position minus your initial position over the duration of the process that it takes you to get there, tf minus ti. This guy here is, let's change colors for that. This guy here is 2 seconds. This one is your initial position, which is minus 30 feet. This is your final position, which is minus 20 feet. All right, so when we come in and do the math, that is minus 20 feet, our final position, minus 30 feet. Got to remember to do the 2 minuses. That'll screw you up if you don't do it that way, over that 2 seconds. All right, so minus minus is plus, so we have minus 20 feet plus 30 feet over 2 seconds. So that's equal to positive 10 feet over 2 seconds. That's 5 meters per second, all right? So that looks good. It gives us a shot at least of winning the race. Let's figure out where he is after those 2 seconds. Okay, so how would we do that? Well, we use basically the same equation, right? This guy here. Now what we can do is we can multiply both sides by tf minus ti and put everything around. So we have this part canceling that thing, so you have xf minus xi is equal to v hat, or v bar, your average velocity times tf minus ti, which is your delta t. All right, so this was our 2 seconds. You want to find that xf, and we can add xi to both sides. So xi is then going to be, originally he was at minus 20 feet, and we add in his speed, which is 4 meters per second, and then multiply that by the time, which is 2 seconds. So that's minus 20 feet plus 2 times 4, which is 8. Well, these should be feet per second. Feet per second. And that ends up being minus 12 feet, right? Or there's no seconds. Second times seconds is cancel out. Okay, so we have minus 12 feet. So he's also gotten closer, obviously, because he's running, but he's already taking the victory lap, high stepping it. So he's going a little bit slower than he had been. And you've got that extra burst of energy, so that adrenaline's pushing you up at up a little bit to speed up, so maybe you can win this race. Don't know. We'll come back and in the last example talk about that, but first we're going to talk about acceleration.